Welcome back, Algebra 2 students, to another Regents review video. This is the Algebra 2 Common Core exam for the June 2017 administration. Again, I'll say it again, this was a challenging Regents for sure. These are going to be the solutions to Part 1, questions 13 through 24 of this exam. These are going to be the harder section of the two. I thought that the beginning section was fine, but then these get trickier as they go. I don't know why, but whatever it is. So since it's hard, that means that you shouldn't cheat. If you're here to cheat, then you're in the very wrong place. Do not, under any circumstances, take these answers and call them your own and put them on a piece of paper. I said it many times. Do not do it. It's so not worth it. Please, you have to try the problems by yourself. I know you could do it, but then if you come here and you cheat, it's not okay. Anyway, enough of my babbling. Make sure you hit that subscribe button down below. Consider becoming a patron on my Patreon page and visit my website at www.nysmathregentsprep.com. Both of those links will be found in the description down below. And as usual, I use the TI Inspire CX Calculator. Very powerful tool. This link can be found on my website as well. Without further ado, let's jump right now to question number 13 of this exam. And we begin with kind of an easy question, and then we're going to get a little bit more tricky. Here we go. A student studying public policy created a model for the population of Detroit, where the population decreased 25% over a decade. Oh boy, is that true. He used the model P equals 714 times 0.75 raised to the D power, where P is a population in thousands, D decades after 2010. Another student, Suzanne, wants to use a model that would predict the population after Y years. Suzanne's model is best represented by what? So here's the thing, folks. What's happening here is they say that one of the students, all right, so he used this equation where, remember that D is in decades. So the difference between this student's survey and Suzanne's survey is she wants to do it in Y years, okay, in Y years. This is Suzanne's model. So it's the major difference is that Suzanne wants to do it by years. The other student just wants to do it by decades. Very big deal. If you want 9 years for Suzanne, she would make Y equal 9. If the other student wanted 9 years, it would be 0.9. You see the difference here? Decades is very different from just single years, okay? So here's what's happening. What we're going to do is we're going to take the 0.75 inside of the student's or the other student's equation, and we're going to raise this to the 1 over 10 power because there's 1 year. Well, how do I explain this? 1/10 represents 1 year of a decade. That's what that means. So it's 1 year per 10 years, which 10 years is a decade. So that's important. You have to know that a decade is 10 years, okay? So if we take 0.75 and raise it to the 1/10 power, we are going to get an answer of 0.9716, okay? 0.9716. So it's very important that you know what a decade is. And let me just write that down here. A decade is 10 years. And that's it. So we're looking for the answer that shows 0.9716. Your answer is choice 3. That is the only difference between these two. We just raise to the 1/10 power, we get choice 3. Pretty simple stuff, peoples. Moving on to number 14. Fairly simple question, not too bad. The probability that Gary and Jane have a child with blue eyes is 0.25. And the probability that they have a child with blonde hair is 0.5. The probability that they have a child with both blue eyes and blonde hair is 0.125. Given this information, the events blue eyes and blonde hair are what? So here's what we're doing, folks. We are going to calculate, or well, not really calculate, we're actually just going to list what we have. So the probability of having a blue-eyed child, okay, is 0.25. They tell us that, okay? The probability of having blonde hair is 0.5. The probability of blue eyes given that the child has blonde hair. Actually, does it say given? No, I'm sorry, both. Both blue eyes and blonde hair is 0.125. That just means both of them, okay? So what we're going to do is we're going to see if it's dependent, independent, or mutually exclusive. So we will do the test for independence, because if we do the test for independence, it also determines it determines dependence as well, okay? Because if the events are not independent, then they have to be dependent. So here's the thing. The test for independence is the following, okay? Let's use the test for independence. The test for independence is the following. If the probability of A and B is equal to the probability of A times the probability of B, then the events are independent, okay? So the probability of A and B. All right, so let's do it. So the probability of A and B is 0.125. The probability of A is 0.25. The probability of B is 0.5. Let A event be the blue eyes and let B event be the blonde hair. Well, if you take these numbers and you multiply them, you do get 125. 0.125, I should say. So since that checks out, the events are immediately independent. Okay? They're not dependent. So that knocks out choice 1 and choice 3. So now it all comes down to, are they mutually exclusive? Okay. Well, mutually exclusive, for mutually exclusive to work, the formula is this. The probability of A or B must equal the probability of A plus the probability of B. And here's the thing. If it was mutually exclusive, so either you could do it with this formula, the probability of A or B equals the probability of A plus the probability of B, or for mutually exclusive, the probability of A and B, events A and B, must be equal to 0. Okay? Since clearly it does not equal 0 just for the sole fact that it's 0.125, it is not mutually exclusive either. So your answer is choice 2. Again, to prove mutually exclusive events, you need to show that the probability of A and B equals 0, or show that the probability of A or B is equal to the probability of A plus the probability of B. I cannot talk tonight with probability. Oh my goodness. And that is your answer, ladies and gentlemen. Choice 2 is the correct answer for that question. All right, moving on to number, what are we doing? 15 now? 15, okay. 15 says, based on climate data that have been collected in Bar Harbor, Maine, the average monthly temperature in degrees Fahrenheit can be modeled by the equation B of X equals that thing. That's a lot. Okay, so this is, oh my goodness. This is Bar Harbor, Maine. Okay. And the same governmental agency collected data from Phoenix, Arizona, and found that the temperatures can be modeled by P of X equals this. Okay. So we have this so far. Which statement cannot be concluded based on the average monthly temperature models X months after starting data collection? All right, let me just read it first, then I'll graph these things. The average monthly temperature variation is more in Bar Harbor, Maine than Phoenix. The midline average monthly temperature for Bar Harbor, Maine is lower than the midline temperature for Phoenix, Arizona. The maximum average monthly temperature for Bar Harbor, Maine is 79 degrees Fahrenheit to the nearest degree, or the minimum average monthly temperature for Phoenix, Arizona is 20 degrees Fahrenheit to the nearest degree. So what we're going to do is I'm going to graph this on my calculator. All right, calculator, here we go. So we have 23 point, oh my goodness gracious, 23.914, jeez, times the sine of 0.508x minus 2.148. I'm typing in the wrong one. Son of a, hold on a second. 0.5 minus 2.116. I don't want that. Plus. I need to make sure that this is typed in correctly. Give me 1 second. Is that, I typed it in right? 23. Come on. Oh, you got, okay, there we go. 23.914 sine of 0.508x minus 2.116 plus 55. Okay, good. That's fine. All right, f of 2 is 20.238, the sine of 0.525 x minus 2.148 Okay. Oh, geez, that took a while. So we have these two graphs. Now, to get these two graphs to show in your calculator screen, go to Menu, go to Windows Zoom, then go to Zoom Fit, and it clearly shows a fitness for you. So, here we go. The red sinusoidal graph is the Arizona graph, and the blue sinusoidal graph is the Bar Harbor, Maine graph. Obviously, Phoenix, Arizona is much hotter than Bar Harbor, Maine. Maine is up north, Arizona is down south, and it is like really bad down there. So, let's take a look at this. The average monthly temperature variation is more in Bar Harbor, Maine than in Phoenix. So here's what it's saying. Temperature variation. Temperature variation is a code word for amplitude. Okay? So it's basically saying, is the amplitude more in Bar Harbor, Maine compared to Phoenix? Okay. Well, the amplitude for Bar Harbor, Maine is 23.9. The amplitude for Arizona is 20.2. So therefore, this is a correct statement. We're looking for the statement that cannot be concluded. Cannot be concluded. So this is actually true. Okay, because the amplitude is higher in Maine than Arizona. All right, number 2, the midline average monthly temperature in Bar Harbor is lower than the midline temperature for Phoenix. So basically, if you take these two graphs and you create a midline through the two, they're saying that the Maine midline is lower than that of the Arizona midline. Well, that's definitely true because it's lower on the graph. So that's true. Okay, so that can't be the answer. The maximum average monthly temperature for Bar Harbor is 79 degrees Fahrenheit to the nearest degree. So basically, they're saying find the maximum value on the blue graph shown on your graphing calculator. So to go to Menu, go to Analyze Graph, then go to Maximum. Click on the blue graph and click before and after the maximum point. This, ladies and gentlemen, that 79.2 is your degree measure. So it is 79 degrees about. Yeah, that's true. Take a look at choice 4. The minimum average monthly temperature for Phoenix is 20 degrees Fahrenheit to the nearest degree. We'll go to Menu, Analyze Graph, Minimum. Click on the red graph. Click on the minimum point. And as you can see, the minimum is 66.5 degrees. I don't know where they're getting 20 degrees Fahrenheit from. So that is your answer. The chances of it being 20 degrees Fahrenheit in Arizona is very rare. I'm just saying. Just pointing it out there. It could snow in the desert, but it's just rare to have 20 degrees Fahrenheit. Moving on to number 16. For x is not equal to 0, which expressions are equivalent to 1 divided by the 6th root of x? This question is annoying. We're going to take this really slow here. Here we go. We're going to take it slowly here. Let's take a look at choice 1, I should say. So option 1, okay? Option 1, we do the following. It's the 6th root of x divided by the cube root of x. So this is the same thing as saying x raised to the 1/6 power divided by x to the 1/3 power, okay? So remember, you could write radicals as exponents. That's how I just did it. So this is your root. Remember, this is your root. There's a 1 here, so that's your power. Remember, power over root? Power over root, that's what I'm doing here, folks. Okay? So now we could simplify this. Since we're dividing, we could actually subtract the exponents. So x to the 1/6 minus 1/3. Okay? When we find the LCD, in this case it is, I think it's 6 here. So when you multiply the top and the bottom by 6 over here, you get an answer of x to the negative 1 over 6 power, okay? When you take 1/6 minus 1/3, okay? So now from here, what's going to happen is we can now take x to the negative 1/6 and push the exponent down to the denominator, because you're really not supposed to have negative exponents. So we have 1 over x raised to the 1 over 6 power, okay? Which is the same thing as saying 1 over the 6th root of x. Ladies and gentlemen, that is your answer. And it shows here which expressions are equivalent to 1 divided by the 6th root of x. That is 1 divided by the 6th root of x. So we know that choice 1, so far so good. Now here's how you could be clever with your answers. Look at this, folks. X to the 1/6 divided by x to the 1/3. Wait a minute, Trevor. I saw that before. Isn't that this right here? Isn't that the same thing? Right? So you don't even need to do work for it. You already know it's going to progress to these steps. So immediately, this is correct, right? So we know it. We're good. So that's definitely true. We're good. Check it off. Wait a minute, Trevor. Option 3 says x to the negative 1/6. Didn't we just do that? Yeah, we did. Isn't x to the 1/6 right over here? So isn't that going to lead to the same result? Of course it is. So therefore, everything here works. Isn't it nice when you do option 1 first and everything leads nicely onto itself? Your answer is choice 4, folks. Everything works. Just for the sole fact that these are the in-between steps of what you did originally. Okay? So, that's it. Option 4. Or choice 4, I should say. Moving on, number 17. A parabola has its focus at 1, 2, and its directrix at y equals negative 2. The equation of this parabola could be what? Okay, so we have a focus of 1, 2, and a directrix of y equals negative 2. Okay, so a couple things that you need to keep in mind. The vertex form of a parabola is y equals 1 over 4p times x minus h squared plus k. All right? Now, you need to know this. Your focus, okay? The focus is always in the form of h comma k plus p, and your directrix is always in the form of y equals k minus p. All right? So we have our focus. It's 1 comma 2. So if our focus is 1 comma 2, that 1 is your h value. That 2 is your k plus p value. Okay? And the directrix we know is y equals negative 2. So that negative 2 has to be k minus p. Okay? So your goal is to find h, k, and p. Well, we already found h. H is 1, right? We got that. H is 1. Now we need to find k and p. But we got a problem here. There's no way that we could solve for k and p by themselves. So what we have to do is we actually need to set up what's called a system of equations. You do it a lot. So what we're going to do is we're going to set up a system of equations relating 2 to k plus p and negative 2 to k minus p. So I'm going to set up a system of equations right now. This is 2 equals k plus p and negative 2 is equal to k minus p. All I did is I made 2 equal this and negative 2 equal this. Great. Watch this. We can now cancel out those p's. We add these up. We get 0 equals 2k. So therefore k equals 0. So that's the other answer. And if you plug k equals 0 back into one of these equations, then your p value must equal the number 2. Great. We just found all of them just by that simple system of equations method. So now here's the dealios. What we're going to do, I'm going to move this first of all. What we're going to do is take all these numbers and we're going to plug them into our formula right there. So we get y equals 1 over 4 times p, which is 2, x minus h, which is 1, squared, plus 0. Ladies and gentlemen, your answer is y equals 1 over 8, x minus 1, quantity squared. Is that answer there? I think it is. First of all, I need to write that neater. Okay. Is that answer there? That answer is choice 4 for that question. All right, not too bad of a question. Make sure that you know focus on directrix and you'll be okay for the exam. Moving on to number 18. The function p of t equals 110e raised to that ridiculous decimal models the population of a city in millions t years after 2010. As of today, consider the following two statements. The current population is 110 million, and the population increases continuously by approximately 3.9% per year. This model supports what? Okay. This question is very, very mean. As of today. So as of today, when you're taking this exam, it doesn't mean June 2017. It means as of today. You could be watching this in June of 2018, August of 2019. I don't care when you're watching this, but as of today, consider the following statements. The current population is 110 million. Absolutely not. That is not true. What it should say is that the population is 110 million in 2010. Because, ladies and gentlemen, that is the initial population. Remember, A equals PE raised to the RT power. This is the PERT formula, right? You've heard of PERT before? P is the principal. Okay? The principal or the initial or starting amount. So that's an incorrect statement. It should say 2010, not current population. So that's wrong. And it says that the population increases continuously by approximately 3.9% per year. Well, yeah, that's true. Because if you take a look at the exponent up here, right? Take a look at the exponent. 0.03922. Well, if you take 0.03922 and you move that decimal place 2 places to the right, you get 3.922%. That's approximately 3.9% per year. So that's correct. So your answer, ladies and gentlemen, is choice 2 for that question. Moving on to number 19. To solve this, Ren multiply both sides by the least common denominator, which statement is true. All right, so we actually need to solve this. So let's take it slow here. In order to solve this equation, we need to find an LCD. This is going to take a little bit, folks, so bear with me. Okay, so your LCD, what you need to do when you are trying to find the LCD, and this is probably the hardest part of the problem, is you're looking for what's common. Okay, I see an x minus 2, an x, and an x squared minus 2x. Well, that x squared minus 2x is good for us because we could actually factor this by x times x minus 2. And these look a lot similar to these. So your LCD is actually, let me write this down. Your least common denominator is actually x times x minus 2. All right? So now what we're going to do is we're just basically going to multiply both the numerator and the denominator by what we need. So this is going to be multiplying by x, x and x. This is x minus 2. This is x minus 2. Sorry, my dog is barking. And this we don't need to change because there's nothing that we need because the denominator is perfect as is. So since that denominator is perfect as is, we don't need to change that fraction because we already have that least common denominator down below. So here we go. What we just did is we just multiplied everything by what we need both on the top and the bottom because remember what you do to the bottom, you must do to the top. Okay. So we get, on the top, we get 2x squared divided by x times x minus 2 minus, actually, you know what? Here's the thing. I'm going to make this plus, and I'm going to make this a negative 11 just because I don't want to get confused with my signs. It's very important about that. Plus a negative 11 times x minus 2 divided by x times x minus 2. Okay. And this is equal to 8 divided by x times x minus 2. Again, that's just factored x times x minus 2. Okay? Now, remember, once we get the same least common denominator, we cancel everything and set the top equal to each other. Let's go ahead and do that. So we get 2x squared minus 11 times x minus 2 equals 8. Distribute that negative 11. Remember, watch your signs. Be careful. As I just made that a plus, that negative is still with us. So we get 2x squared minus 11x plus 22 equals 8. Okay, we're almost done. Subtract that 8 on both sides. Okay, we get 2x squared minus 11x plus a 14. Plus 14 equals 0. Now, however your teacher tells you how to do this, fine with me. But the problem is we cannot factor a GCF out. Okay, we cannot factor a GCF. But the problem is we need that 2 to be a 1. Because you cannot factor trinomials where the a term is not equal to 1. So what I tell my students is take the first term and multiply it to the last term. This is called AC method factoring. Okay, it's called the AC method. So now what we're going to do is we're going to multiply those two numbers. We get x squared minus 11x plus 2 times 14 is 28. It equals 0. Now that's a 1. Perfect. We needed that. So now let's go ahead and factor using the AM method. What adds to negative 11 and multiplies to give you 28? Well, we get x minus 7, x minus 4, set that equal to 0. Let's just double check. Negative 7 times negative 4 is positive 28. Negative 7 plus negative 4 is equal to negative 11. Now, with the AC method of factoring, you need to divide these numbers by a 2 because that 2 is locked in here somewhere. So we have to bring it back out again. So I'm going to take that 2. I'm going to move it up front. Take that 2. I'm going to move it up front. Only if the fraction cannot be simplified. What's nice about the second binomial is that negative 4 and the 2 could reduce down to negative 2. So we don't even need to move anything. But this, we got to move up there. So this becomes 2x minus 7, x minus 2. And again, this has to move up because that 2 cannot evenly go into the 7. Okay? Set this equal to 0 and solve for x. So we get x equals 7 halves and x is equal to 2. So these, ladies and gentlemen, are your possible solutions to this equation. But, let me just write it up here. But if we get 7 halves and 2, which of these don't work? X equals 2 does not work because it's an extraneous solution. The minute you plug it into this denominator, the whole thing blows up. 2 minus 2 is 0. You cannot divide by 0, so which statement is true? Choice 1. The number 2 is an extraneous solution, so therefore the answer to this one is choice 1 for that question. Moving on to number 20. Given f of 9 equals negative 2, which function can be used to generate the sequence negative 8, negative 7.25, negative 6.5, and negative 5.75? Sorry about that. Okay, so now in this case, here's what we need to do. We need to find the formula that generates this a sub 1, a sub 2, a sub 3, a sub 4. Let's go ahead and do it. So we have to find either the common difference or the common ratio. Okay? In this case, it's probably not a good idea to find the common difference. Actually, you know what? The common difference is subtracting 0.75, right? So if you want to make your life easy, if you really want to make your life really simple, take the number 1, n equals 1, and plug it into all of these answers and see which one gives you that negative 8, okay? If I take n equals 1, which is the first term, plug into all these answers, let's see what we get. So we have negative 8 plus 0.75 times 1. Does that equal negative 8? No, because 1 times 0.75 is 0.75. Negative 8 plus 0.75 is negative 7.25. So that's not true. So if you plug in 1, that blows up. Let's try the second one. Negative 8 minus 0.75 times n minus 1. Well, negative 8 minus 0.75 times 1 minus 1. Well, that's just 0, so that cancels. Do we get negative 8? Yeah, okay. Let's try n equals 2 for that one. Now let's try n equals 2 for the second equation. If you take 2 and you plug it in, right, we get negative 8 minus 0.75 times 2 minus 1. We get negative 8 minus 0.75, and that gives you negative 7.25. So far, that looks like a good answer. Okay. Now, just for the heck of it, let's go ahead and plug in f of 9, because it seems like that those first couple terms are working. Let's go ahead and plug in f of 9 and see if it works. So go right here, f of 9. That is equal to negative 8 minus 0.75 times 9 minus 1. If I go to my calculator, okay, I'm going to take negative 8, come on, thank you, minus 0.75 times 9 minus 1. That gives you negative 14. Oh, wait a minute. If that's negative 14, it should be negative 2. That answer is wrong. So all I'm doing, folks, and if you're sitting there confused, like, I don't even know what he's doing, all I'm doing is I'm taking the number term, so like 1, 2, and I'm seeing if it equals what they gave us, okay? So let's go ahead to number 3 and plug in n equals 1, n equals 2, and so forth. So n equals 1, we get negative 8.75 plus 0.75 times 1. Well, that gives us negative 8, because negative 8.75 plus 0.75, that gives you negative 8. Let's try n equals 2. Negative 8.75 plus 0.75 times 2. Well, that just gives you 1.5. Negative 8.75 plus 1.5, that gives you negative 7.25. So far, the first two terms work. Let's go ahead and evaluate f of 9. Let's plug 9 in. Negative 8.75 plus 0.75 times 9. When we go to our calculator, let's see if it equals. Oh, it equals negative 2? Sweet. Your answer is choice 3. Choice 4 doesn't work. And that's how you do that question. Now, if you wanted to do it like the common difference way, the common difference is you're adding 0.75 each term. But the reason why this is not the first term is that they failed to subtract a 1. So if you made this number here a negative 8.75 and you kept it as that and you made this n minus 1, then it would have worked. But unfortunately, they didn't do that to keep it as the explicit form. So your answer for that one is choice 3, and it works. Done. Moving on. 21. The function f of x equals 2 raised to the negative 0.25x times sine of pi over 2x represents a damped sound wave function. What is the average rate of change for this function on the interval from negative 7 to 7 to the nearest hundredth? Okay. This made me sad. This made me sad. Very sad. You see here, folks, on your calculator, you wouldn't have gotten the right answer if you didn't put your calculator in radian mode. Your calculator is supposed to be in degree mode, but what they decided to do is say, hey, we're going to screw around with the kids for a little bit. We're going to change the document settings to radian mode, all right? And we are going to kind of screw with their heads a little bit. So what I'm going to do is I'm going to evaluate f of negative 7 and f of 7. So here's what I'm going to do. I'm going to plug in this function into my graph. And you'll see why I'm doing it in a moment. F raised to the negative 0.25 x times the sine of pi over 2 x. Okay, so we get this, some ridiculous function. And here's what I'm going to do. You see how in your calculator it's stored in F1? If you click on control doc, add a calculator, okay? I'm going to find the average rate of change. You know that the average rate of change is the change in y over the change in x. y2 minus y1 over x2 minus x1. What I'm going to do is this. Here we go. Do control divide. Type in F1, because it's stored in F1. F1 of negative 7 minus F1 of 7 divided by negative 7 minus 7. And look at what it does for you. It actually calculates the slope that you need. Your answer is negative 0.26. All I did in the calculator is y2 minus y1 over x minus x1. What this did at the top here, ladies and gentlemen, is this is a code in the calculator for finding the y values. Okay? So your answer is negative 0.26 rounded to the nearest hundredth, and that is in radian mode in your calculator. That's what made this question hard. But all I did really is I just did the change in y over the change in x. That's your slope formula. All right. Moving on to number 22. 22 was annoying. Mallory wants to buy a new window for her air conditioning unit. The cost of the unit is $329.99. If she plans to run the unit 3 months out of the year for an annual operating cost of $108.78, which function models the cost per year over the lifetime of the unit C of N in terms of the number of years N that she owns the air conditioner. Okay, so a couple things that we want to highlight here that are important. First and foremost, models the cost per year over the lifetime of the unit, C of N, in terms of the number of years. So, here's the thing. C of N, in this case, which represents the, I believe, yeah, the cost function, all right? C of N represents the cost function. C of N is indicated by $329.99. That is the amount of money that she paid for the unit in the first place. That's called the down payment. And she's adding on the $108.78 per year. Ladies and gentlemen, this is the total running cost in N years. But that's not what the question's saying. The question is saying, C of N in terms of the number of years. In terms of the number of years. So what she wants to do is she wants to take her cost function, which is in years, and convert it to per years. Okay? Per years. So you would be prone to pick choice 1. That looks like a really good answer. But unfortunately, that is not the answer. Your answer is actually choice 3, because choice 3 converts to per year. Okay? So, that's about it, because, okay, so there is some miscellaneous information that is totally irrelevant. She plans to run the unit 3 months out of the year. That 3 months has nothing to do with it. That 3 months tried to trick you. They wanted you to take 3 months and multiply it by 108.78 to get this one over here or this one down here. So choices 4 and 2 are totally irrelevant because that 3 months had nothing to do with the problem. It all depended on the per year. So your answer is choice 3. Moving on to number 23, the expression of this can be rewritten as what? So you need to simplify this as much as possible. What I'm going to do is I'm going to take negative 3x squared minus 5x plus 2. And divide it by x to the third plus 2x squared. So what we need to do is we need to simplify the top by, again, AC factoring, all right? So what we need to think about is take that negative 3, multiply it to the 2, okay? We get x squared minus 5x minus 6 divided by x squared times x plus 2. That is what you get when you factor out the That is what you get when you factor out the greatest common factor on the bottom. Now, let's keep going with this. I'm going to factor the top. What adds to negative 5 and multiplies to give you negative 6? Now, it's factorable because before that a term was negative 3, we need that a term to be 1. So that gives us x minus 6, x plus 1, divided by x squared, x plus 2. Okay, so now what we need to do is take the top. Okay, we need to take that top and we need to divide everything by negative 3. The reason why we have to divide by negative 3 is for the sole fact that that negative 3 is still locked inside of here. So we need to take that x minus 6 and x plus 1 and divide these terms by a negative 3. Okay, if it simplifies, great. If it doesn't, we got to move it up front. So these simplify to x plus 2. And this, we got to simplify. We got to move that 3 up front. This becomes 3x minus 1. All I did is I just took that negative and moved it up to the negative 1. That makes the most sense. And we're just going to continue the problem. Divided by x squared, x plus 2. All right? So now from here, we get x squared and x squared. They cancel. And we get 3x minus 1 over x squared. So now what we need to do is we need to do I-heart division. Okay, that's what most teachers call it, I-heart division. We need to split these up into 2 separate fractions and solve. So we get 3x over x squared minus 1 over x squared. That x and the x squared could cancel down to an x on the bottom, and this remains the same. So we get 3 over x minus, let's see, minus 1 over x. Is that a minus sign that I'm, hold on a second, wait 1 minute. You know what? Hold on 1 second. Let me back it up for a second. I want to keep that negative right there. Just because I think it would be more helpful. Watch. So all right. So forget what I just did before. It's not that it's wrong. Okay. I just want to keep it there. So we get x plus 2, and we get negative 3x plus 1. Okay. Let's try this way instead. We cancel those, and we get negative 3x plus 1 over x squared. I heart division, so we get negative 3x over x squared plus 1 over x squared. I'm going to simplify this. We get x on the bottom. We get negative 3 over x plus 1 over x squared. Okay. Now what we need to do, and if you look at your answer choices, everything's manipulated with negative exponents. So what they want you to do is take this x, move it up here, make that a negative 1. Take that x squared, move it up here, make that an x to the negative 2. So this is negative 3x to the negative 1 plus x to the negative 2. Because since the exponents are positive down here, if you move it up, you make it negative. That corresponds to choice 4. And that, ladies and gentlemen, is the answer to that question. I do not like the fact that they start manipulating exponents and making things negative, because that's really an improper way to write exponents. You really shouldn't be writing negative exponents, but whatever, that is the answer. Moving on to number 24. Jasmine decides to put $100 in a savings account each month. The account pays 3% annual interest, compounded monthly. How much money S will Jasmine have after 1 year? Okay, so 3%. We got $100 after 1 year. So, and it's compounded monthly. Now, the problem is it's asking you for 1 year. 1 year. So what we got to do is we got to take 0.03 interest and divide it by 12, the amount of months in a year, and we get 0.0025. So, ladies and gentlemen, this 0.0025 is the monthly compound. Okay, and the reason why I had to convert it is because, as you can see, all of these answers have 12s. 12, 12, 12, 12. And that means that these are in month terms. These are not in year terms, okay? So we had to convert that right there. So now you just plug it into the formula from your reference sheet, and your answer, and she's trying to find how much money, so we're finding a summation formula. Your answer is going to be choice 2 if you plug in all that information, with the 100 as your initial amount, or your A sub 1, and this is going to be your monthly compounds. All right, and that's it. That's the end of this video. Sweet, that's the end of the multiple choice section. I thought that the second half of the multiple choice was definitely more difficult than the first. Let me know what your opinion is in the comments below. Hit that subscribe button down below. Consider becoming a patron on my Patreon page, and visit my website at www.nysmathregionsprep.com for more math content in Algebra 2 and future high school mathematics subjects such as calculus. And I will see you soon.